Correct, right. That's the idea, yeah. Mention that.
Okay, welcome everybody. After our coffee break, I hope you enjoyed the coffee, and even more, I hope you enjoyed the discussions you had with your colleagues. And I hope you will keep on enjoying the discussions as they goes on. We're starting off with a product update from David Hawla. He's already joined me on the stage here. David has a doctorate in computational mechanics from the University of Cape Town, and for 6 years he worked as an FEA analyst and manager at the CSIR Aeronautics Division. He has worked for HKS, Abacus, and Dassault Systems since 1989. He was probably employee number 3 or something like that.
No, about 30.
He started on development projects in Abacus Standard, then managed the development of physics modeling aspects in Abacus CAE for 9 years. He was Abacus QA director for 7 years, R&D technology director for SIM and ODB databases for 5 years, and now he's the R&D technology director for durability and fatigue since February 2015. And as I mentioned, he'll go through product updates, new features in recent developments. Thank you. Let's welcome David.
All right, thanks, Pavel. You can see Pavel and I and Giovanni de Moraes jointly prepared this, and you'll hear more from Giovanni in some later sessions. Got to learn how to figure out where to point this. This is the usual non-disclosure that I just skipped at, that, you know, we haven't actually released 2017 yet, so there's the potential that some of the things I say here are not necessarily going to show up, but in fact, we've already put the code in the can, basically, so for the general availability of FESafe 2017. So, whoops. Going a little too fast. So I'm going to give you a little flavor of the durability app in the 3D Experience platform, and then I'm going to cover the sort of main, a bunch of main topics, showing you some of the progression of development, and we'll finish off with some general enhancements that don't sort of fit into one of the big buckets, but are things you guys have asked for. So the durability validation app is our first entry into providing FESafe technology on the 3D Experience platform. Right, it integrates the CAD with data management, and we piggyback on another application called structural validation. It's focused really on designer engineers, and partly what that means, it's very limited in capability, so it keeps it a little simpler, all right, which means it's not the best for experts, of course, right? It's been available now for over a year. There have been some changes to structural validation app in 17X, and those then naturally flow through into the durability validation app. So one of the things you see here is It's this sort of pretty much the whole interface, okay? You get your simulation manager over here, tells you all the features, includes all of the Abacus or FEA related features, okay, and then it includes some of the loading history features and of course surface finish features that go with the fatigue analysis, right? And you get your nice sort of checklist here. You know, if you've forgotten to say assign a material, then instead of a green arrow, a check mark, you'd have a red box there, and it'll be just a little reminder, oh yeah, I forgot, you know, you still have to do that. It won't let you start the execution and so forth. Right, and normally it's sort of in the order that people flow going down. You see there's an open square box for connections because, well, you may not need connections in this, right? In this case, you don't because you actually have contact that's effectively coupling the parts, right? And this is the post-processing. You can control these things, and these are the, you know, the small number of actions you can do in this app. So you assign the material once in this app, all right? So it's the same material assignment used for rendering as well as for the Abacus part, as well as for the fatigue analysis, and I've just highlighted the fatigue aspects. Of course, you see it doesn't cover all, whoops, it doesn't cover all of the, it covers the strain-based fatigue methods here. It only covers 3 of the methods today. And it's very simple in terms of it just takes all the loading and it only just cycles that, all of it. You know, you can't have multiple load cases and scale and combines. That'll come in our expert app so there are a few things that have changed. One of the things people asked is the structural validation and durability validation have only did a nonlinear analysis, but now you can actually change it to a linear analysis. So we will be releasing a expert app, just the first of many releases sometime in the new year, probably the middle, more like the middle. All right, so now we're going to switch to one of the main topics, and in fact there's a lot of Weld papers in this user group meeting. So this just goes through some, I've included some enhancements that were made in a few releases back, because it turns out when I talk to a lot of customers are still using fairly old releases. So it's a bit of a reminder of some of the important enhancements there. So back in 6503, we enhanced it to support Nastran ACM2 elements. And as a reminder, you can do spot welds with Abacus Nastran, ANSYS beam elements, Abacus fasteners, Nastran ACM2, of course, welds with multiple sheets, automatically detect the thickness and nugget size. And of course, this is all based on Verity, in fact, right? The Verity method requires quite a bit of information for each weld, and in our earlier releases, you had to enter all of that information. You had to enter these red elements here, the nodes along there in the dots, and you had to give the starting element and the starting node and so forth. What we do now with what we call our weld finder capability is you actually just give the blue elements, all right, the blue, the filler material, and then we will find all that other information automatically. Now, of course, if the mesh, this is a beautiful mesh, it'll work perfectly. If you got complicated curves and tet elements and things like that, it's definitely trickier. You might have to play with a few tuning parameters. to actually get it to detect properly and so forth, but it definitely speeds up your process very significantly. We also did a couple of other robustness improvements in the Weld Finder, and we've actually been doing even more in 2017. So we had started with the solids, Weld Finder for the solids. In 2016, we added a Weld Finder for shells. We also, in 2017, we discovered we had a bit of an inconsistency with the solids between top and bottom conventions, and we straightened that out. One of the things we do get asked quite a bit is, what about multi-axial fatigue? We have a normal stress-based algorithm is the main one, right? We also have a shear-based one where it's shear dominated. We've been working on multi-axial. We had to renegotiate our contract with our agreement with Patel. That took a little longer than we expected. So we've done quite a lot of the work, and we hope to release it sometime next year. So we enhanced NASTRA and C-weld elements are quite popular. For spot welds, they have a variety of forms. FESAFE 2017 supports all the point-to-point and the point-to-patch. Just out of interest, how many people here are NASTRAN users? 0. Okay, I'm just going to skip NASTRAN slides. How many are ANSYS users? Yeah, no, I knew there were quite a few more ANSYS users. Anyone not NASTRA, anyone using not NASTRA, not Abacus, and not, what did I say? Neither ANSYS, Abacus, or NASTRAN. Anybody using something else? Okay, good. All right, so we did, in the 2016 and before, you would see the top level menu was called Verity. We have actually changed that to weld preparation. It's a bit more descriptive in some way, but also it's part of the change to make it a bit clearer on whose IP is what. Some of the IP is ours, some of it's Patel's. In some cases, some of our log files just said structural stress, and we've gone and added in there Patel structural stress to make sure we've attributed the IP correctly. We did conclude a good near agreement with them early in the year, and that will allow us to include Verity not as a pure add-on, but in our extended packaging. And it also will allow us to include Verity calculations in a future 3D Experience durability app. So, did I miss one? Nope. Switching to FKM, we kept getting quite a lot of requests for companies that are either in German-speaking areas or Northern Europe or deal with German or suppliers to German auto companies. They are required to use FKM, so we've added that in. We did a couple of iterations on it, including with a German company, and they helped us, and we think we've covered all the main aspects. We used the 6th edition. We're not doing the welded parts yet because we think we have enough other welded capabilities at this point. It's the local stress thing. If you are going to use the FKM guidelines, you have to get a copy of the guidelines yourself because otherwise you don't understand all the parameters, right? So there's some new, material information that you have to give. We do, in fact, have from the guidelines, we had permission to include their database of ferrous materials and aluminum materials. Whoops. I thought this was such an easy little thing to use, but I keep hitting the wrong button. So we don't load those automatically because they are actually quite big, but you know, they're in your installation, they're pretty easy to find. Of course, you can always add your own. And we reuse the Taylor parameter L for part of the search depth, the stuff that we use, the Taylor parameter being used for the TCD method, right? So there's a bit of detail here that I'm going to skip to save some time. This is the interface. Basically, it's your same way when you're assigning an algorithm. You go through here. When you do that, same process. You choose which mean stress correction method. We implemented these 5 methods here. And then you fill in the relevant factors here. There's some details. You might want to look in your proceedings afterwards if you're really interested in following all of these things. You know, you might need to use different, for example, there's this technological and section factor and so forth. You may need to use different factors in different regions. So obviously, you just divide your model up into different groups, and you assign the algorithm on a group-by-group basis, and then set the tuning parameters as needed, right? So we do proportional and non-proportional. For non-proportional, you have to split it based on the guidelines. So it's not the greatest, but it's the way the guidelines work. They have, I think you have to set some additional factors in there as well when you go non-proportional. So if you really spot this, this is really infinite life method. You'd have only put repeats of about 5 here. I mean, I don't know what I was thinking. That should be more like 5 million or something. One of the things to remember, if you do go this route, is don't confuse it with FRF or FOS, where greater than 1 is good, is safe. With FKM, their measure is a term called utilization. So it's a bit more like damage. So under 1 is good, of course, right? So switching to TCD, if you recall, this is the stress at the notch that determines the initiation of cracks. If you sample the stress at the critical distance, this will actually determine whether that crack will actually propagate. So this is another infinite life method. It's used if you can tolerate small cracks that you know are not going to grow. So several companies dealing with powertrain engine like this method because they can accept those small non-propagating cracks. So here's an example of it. It typically uses the FRF, FOS style thing. So if you look at the colors, it's not the best picture yet. The surface FRF shows you it's in the red zone here. And with the TCD, you're way higher. You have considerably higher FRF. So the interface is really quite simple. Not much you actually have to enter. Probably the trickiest part is to make sure that your element sizes near the surface, around the notches and so forth, are on the order of the L/2 where L is that Taylor critical distance parameter. All right. So you do have to provide in the material data the critical distance. We have it in some of our materials. We've made a few more improvements in the robustness of the surge through the thickness from the surface into the solid. Of course, this only works with solids, right? Not shells, because you don't have a way to pick up the gradient particularly. It's not. We've also improved the handling of, the penta, second order penta, and permanent elements and so forth. And we're continuing to look into, doing research on this, especially with considering, at the moment, we only do principal stress or normal stress method, a critical plane method at the critical point, or the line method, of course. But we are looking at considering additional algorithms that include a combination of normal and shear. I can't say when that will come in the code. So, switching to vibration fatigue. So we've had time domain vibration fatigue for about 5 years. You read the modal stresses and the generalized displacements for the modal dynamic analysis. And then effectively we're using standard scale and combine internally in FE-Safe to calculate stress histories at each element node. What you don't want to do is in the Abacus or Nastran or ANSYS modal dynamic analysis output stress frames at every increment, because you just generate humongous data output files. You really want to do the scale and combine within FE-Safe itself. So about 3 years ago or so, we introduced the frequency domain method, starting just with the Dirlich method with von Mises stress. Giovanni's going to talk some more about this, right? Yep. So just to go back, the main things we've done in the last couple of releases on the time domain is really just improve the workflow. We had a couple of awkward ways to have to force you to set the models up, the loading definitions up. We've made it considerably easier for Abacus, definitely easier for ANSYS and Nastran, but there's still a little room for improvement on those latter two. Just to show you briefly, it's this: you import the data, the finite element model for a. Okay, hang on. That was just to be careful here. That was time domain. I'm switching to frequency domain. The dialog box actually looks fairly similar for the two of them. This is the one for frequency domain. You put in where your modal stresses are, your generalized displacements, the source of that. You can say whether it's the same file or not, which is mostly for Abacus. For other programs, it's typically different. And if necessary, you can you need to tweak the thing. The default, we set the default up here appropriate to what comes out of Nastran or ANSYS or Abacus, right? And then you enter the PSD, right? And we auto-generate the load definition, right? So you end up with this PSD loading block created for you with everything, the scale and combine all set up. So you can this slide is just to show you the progression of the technology. When we started in the frequency domain, after Dirlich, that was before 6.5 even, right? In 6.4, we then added critical plane method for the normal only, then went to normal or shear, and the latest is we can combine them. Just a little taste for one of the things we implemented is this Tovo and Benasiotti method. Dr. Lee earlier this morning talked about 2 versions of Tovo Benasiotti, but I don't think any of the cases he talked about included mean stress effects. Right. So, and one of the advantages of the TB method is that it can include mean stress effects more effectively. Well, it can include it. The Dirlich method and the ones he looked at earlier didn't include that. And so you can see with the Dirlich in this case, you're over-predicting the life. You know, it's 6 million versus when you include the mean stress effects, it has quite a big difference in this case. All right. So one of the things that can be a pain is to generate the PSD matrix, especially if you have time signals. All right, so we have an option. We added that in FESAFE 2016 already. Is if you have a bunch of time signals for a bunch of channels, you know, for example, this is a kind of more of a cartoon thing. You'd have actually typically more channels than this, right? And you have to generate the autocorrelations and the cross-spectral densities, and we can generate that for you automatically now. In fact, that was from a suggestion from Dr. Lee. So one thing we also did was tweak the Dirlich method to add a cutoff on the integration over the stress ranges. This actually can improve the values of the Dirlich method. And of course, it's also built into the Tovar and Bettenascioto method. So ANSYS Workbench Integration. So one of our customers was very interested in using Workbench for simplified workflows rather than using full ANSYS Mechanical and the full FESAFE GUI. For a class of problems, they figured they could make the process of solving some of those workflows more repeatable, more reliable, less error prone. And so we implemented, and we realized, oh, this could be useful for quite a few other ANSYS users. So we implemented, we had an older version, and we redid it completely in 2016. And we believe it's in much better shape now. So this shows you the interface. You can, you know, this is sort of a typical workflow panel data entry panel in Workbench. You can control the material selection. Of course, the key thing is we only do, the data set sequence style, okay? So your ANSYS FEA would be a sequence of data sets, and you refer to those. It only deals with a single block, so as you can see, it's a simplified workflow. If you, whoops, I didn't quite finish there. If you do need to use FESAFE, whoa, down to 1 minute. Okay, I better move it a little quickly on there. So we've added an eyesight component. We did a little tweaks to it to give it a bit more flexibility in 2016. We worked with Stefan Dietz and the development team for Flex Bodies and SimPack. And you can now solve this workflow as well. Okay, and you've seen actually, I saw several people have taken my slide. We've done a lot of work on improving batch processes. So eyesight allows you to sort of drive FESAFE in a batch-like way. Tosca allows you to do that, but people sometimes just want to do it themselves as well, scripted and so forth. So we did quite a lot of work on that. And, and one of the key things that came out was the ability to export the whole project file, so you can ship it and run the analysis on on another machine like your compute cluster. So I'm going to have to skip over that. You'll have to check that. I think we support all our ANSYS, all the ANSYS versions. Of course, we're always going to be up to date with Abacus. Several people talked about that. Basically, the idea here is you can launch the database from the main FESafe window. It's not the best. It's not perfect integration. We still have a way to go, but a couple more algorithms we've added in 2016, and you see a bunch of general enhancements that don't fit into particular categories. You might spot something you might have requested here. And in 2017, we added a bunch more based on specific requests from various auto companies. That's it. So I'm not taking questions now because we're going to have the Q&A at the end of the day, right? Just before cake.
Thank you, David. I was just going to mention, we'll not be taking questions for David. At this time, we'll have a QA session at the end of the day where all of us will be here on stage answering the questions. So we'll move on in the interest of